So we will start the lesson. So last time I introduced the basic assembly concepts. So we started the tutorial, and the tutorial will be continued later. So we discuss about the different mate types. We started with coincident, then we went to concentric, then distance, then angle, parallel, perpendicular, tangent, those kind of things. And we started this tutorial, and I ask you to try to complete this. Anyway, we are going to do this in the last hour. So in the last hour, we will look at the second tutorial also. So these two tutorials will be discussed today, and you can try at home. So here we have a thread mate. So we will do the thread mate later. So when you scroll this, so when you rotate this, this should go up and down. So we will do that thread mate later, but for the time being, just assemble this thing and get used to the environment. So this one also, when you rotate this handle, uh, this jaw should go up, back and forward. So we will look at that thread mate later, but for the time being, assemble the other parts and get used to the software. So we will look at some more concepts today. So we are going to look at this multiple mate mode. What do you mean by multiple mate mode? Now when you do a assembly, suppose you have 4 bolts like this. So if you have 4 bolts, for each bolt we have to have 3 mates to get it fully defined. So we need to have 3 for here, 3 for here, 3 for here, 3 for here, altogether 12 mates I have to do. So it's a very time consuming process. So to avoid that one, we can use this multiple advanced method. Here everyone shares the same surface here. So everyone will share this common face. So we can use that property to assemble these bolts quickly. So rather than going through each and every bolt one by one, 3 mates here, 3 mates here, 3 here, 3 here, we can reduce that process by taking this common surface. So I will take this model and show you how to do this. We will go through our notes part files. So I'm going to browse my part files. So I'm using this drag and drop method from today. So we will I'm browsing the folders which have the part files. So this is the folder we need, 1230. So I will start. Don't just drag and drop from here. Then it is a part file. So I have to start from assembly mode. I'm going to get this base plate. Already the mate has been done for you, but I will not take this. I'll just take this base plate here. Now I'll take bolts. Now we can take 4 bolts for this process. So if you do with the traditional methods, you have to assemble this 3 times, this 3 times, 3 times, 3 times, 12 mates. So that is a time consuming process. So if you just do it in a normal manner, we can just do this way. So I just refresh the last week lesson a little bit. Just you can have concentric like this. Done. Then you can have coincident like this. Done. Now this is still rotating. So if you want, you can stop that. So easiest way is to get the parallel phases. So I'll just take this parallel phase. From this one we can do. Now this took me 3 operations. So I have to do 3 operations. So every bolt I have to do 3. Then it's 12. So suppose if you do a vehicle assembly, how many bolts you have? How many nuts you have? So this is going to be a tedious task. So to avoid those repetitions, we have other advanced methods also. Later we discuss one by one. So we are introducing methods one by one. So now I can't do it again and again. So we will do what? We will use this common method called multiple method. So okay. Now I will use this made tool here. So there is a method called here multiple made modes. So you have to enable this. So when you enable this multiple made mode, it will ask you this common surface. So this is the common reference we need. Everyone will share this common reference. So then what we can do is we can select the faces like this at once. So you can see everyone is now aligned to that uh, single face. So everyone is now aligned. All 4 are sharing this one, and I can press OK. Now there is no other common surfaces, so you have to get used to the normal tools. So we have to use anyway. We have to use these normal tools here. Uh, so I am reducing some steps, not everything. But there are other advanced ways of doing this. We will look at that later. So for the time being, we have to run that 4 times. So when I press OK now, I have these things done for me. So these 4 I didn't do actually. I selected only one common face and I did 4 coincidence and concentric. Then still these bolts are rotating. You can stop them. So I will do it again and show you the process. Uh, Go to mate here. Select this multiple mate modes and common face, common reference. This is the common reference. Then the others you can just select one by one. Don't press OK here. Select everything and press OK. So one by one and press OK now. Now you have to switch to the normal methods. You can untick this too. Now I am back to the normal mates. So you can assemble by normal methods. I think this is somewhere here. So you can assemble this way. And press OK. And if you want, you can stop this rotation. Simply I am taking the faces here. Or else you can take the planes. Now if you want to take the planes, we will look at something like this. Front plane here and parallel face here. So that can be also taken. And if you just take it like this, front plane here and this face. So plane and faces can be also selected, or else you can select this plane and the middle plane here. So plane to plane machine mating can be also done. So this way we can fully assemble the design, and you will see no minus sign here, but here there's a one minus sign. That means this can be rotated. These can't be rotated. So this is almost fully defined part assembly. Any questions? Please tell me. So we discuss this tool at the moment. So if you finish with that, I will go through these advanced things, uh, smart tools. Any questions about the previous one? So if there are no questions, I will move on to the smart methods. So example, we'll take an example and show you. Now I want to assemble this pin to this hole. So the normal usual methods will be we select the faces C and inside faces and use the concentric mate. But without doing that, we can actually drag and drop and apply this concentric mate by dragging. So we can drag the uh, part and assemble to this main body then automatically the concentric symbol will appear. So automatically it will happen. I need to just drag and drop. So how can I do this kind of example? Now we'll show you. So I will take the file, take a new file. So I'm taking this figure 1235 folder. We have the base. I will drag and drop the base, and we have the screw. So usual methods will be we will just normally use this smart tool here, just normal mates, and we will just select these two and we will do it. That so that's the normal mechanism. Everyone will follow that. So we can just select this one, and do a simple mate. So this is rotating. We can stop that even. So if you want to stop that, you can just select these holes easily and stop it. So if you don't worry about the parent-child relations, just do it like that. So it's done. So now I'm not going to talk about that method. So all these three were done by me. So we can reduce our time if you use the smart tools. Now, what can we do now? So we start the mate tool. Sorry, we can't go through this mate tool for this process. So if you just look at this one, we have advanced mechanical things. Those things will not have the things I'm not talking to now. So we can't follow these things. Later we will discuss these things in detail. Now I have to use another tool here called move components. So you have the rotate component. So to rotate means sometimes you need to take these orientations, something like this. So sometimes when you drag and drop, this may not come in the correct orientation. So you need to rotate the parts and make it equivalent to the assemble model. So sometimes when you have this kind of a thing and try to assemble, it may not assemble correctly. So those things will happen. So better you have it oriented correctly according to the final outcome. So we have pre-drag, we have delta y, delta x, those things, lot of methods available. Just for the time being, just I use the pre-drag. But I'm not talking about that. I'm going to talk about the smart move method. So if you just follow this one, these two are together. So I will start move components, and the rotate is down below here, rotate is here. So I have to start the smart tool here. So move can be just a normal move like that or a smart move. So if you start the smart move, you cannot just come and drag it here. It will not work that way. You have to double click on this. So when you double click on the face here, this is turned into a clip mode, and this is going to be transparent. So you can just drag and drop to this hole. So you can see it's now working. Concentric symbols appear. That thing automatically happen. Press OK. Now if you want to do a smart thing for this surface, can be done. Double click on this, drag and drop to here. You can see some mates happens. It's not a very accurate mate. So what we can do is we can do this way. So you can see a symbol appears, coincident symbol appears. Now the mate has been done. So this is a smart move. So I did it very quickly. So I didn't select lot of faces. So I will do it again for you. So these can be used in your assignments and the project too. So I have this kind of a situation. Rather than going here, we will go up move tool. Under move tool, you have smart methods. Double click on this, drag and drop, and wait until the symbol appears. It's okay now. Concentric automatically happen. Okay. Then you can double click on this face and drag and drop to this face. So the coincident happens. So this is coincident automatically happen. And we can try to align the holes also. Double click on this. it's not working. So it's difficult to align the holes because it's not coinciding. Software is not intelligent enough to align to that hole, so it's not working for the hole. So smart tool is not working for the hole. You can just use a normal mate and do that. Sometime you can try whether it's working. If it is working, tell me also. So this is the way. So I did these two from smart method. This is a normal manual method. Any questions? Please yeah, tell me. I will repeat this fully.
So can you do the smart method once again? How to select and do it?
So don't go through this button. Go through the move tool. Just enable this. You have to double click here. I'm clicking twice. Double click on the surface here. Then it will turn into a transparent mode and a clip appears. Then you quickly drag and drop to the correct hole here. Then the software will take that mate and wait until the symbol appears. You can feel it. Actually, you can feel it when it happens. Your cursor will jump to that correct face. Double click on this, and I'm rotating this because I have to show the computer that this surface is the mating surface. So you can drag and just put it like this. So you can see the symbol appears. And this is if this is not okay, you can select the other methods also. That's how it works.
Thank you, sir.
Okay. So in the exam or any project work, you can use any method. So we are not going to check the method you are using, but use the easiest way and the fastest way. Sometimes these methods will be faster than the traditional methods. So we will discuss some more advanced things in the coming sessions. Uh, and this is another application. So I will show you the same method from this example also. So you can drag and drop and make it. So I will show with the vice Joe also. So I'll go back to the previous folders. I think this is the folder 12.9. So vice body can be taken like this. Then I will get the vice Joe. Already some mates happen, so I'll just delete them. I want these to mate with this, so we can use the smart face. Move tool, go to smart, double click on this face. This will be transparent. Drag and drop until this face. So you can see the symbol appears, mating happen. And if you want, you can double click on this and connect this. So mating happens. So we can see two. Actually, three has been happened. Actually, this is still to slide in. So some one is redundant. One mate is redundant. So this is a parallel mate he has selected. Coincident here. So this is since this is parallel, you can slide it. But if you make it coincident, it will not slide. It will come and hit. So now it's not moving. Fixed. So you can see minus sign is disabled. Vanishes. So these are the ways we can use the smart tool. You can do this also and see. Any questions, please tell me. Okay, so we will look at another method. So this is also kind of a smart way. See here, we are going to look at how the geometry has been given in both files. So I'm going to use the geometrical properties and try to assemble. This is also very similar to smart methods. They have given just different names. So we will look at this file. So this is the part I'm going to take. So I can take whatever I like, whether this one or this one. So here you can see my SolidWorks screen has been divided into uh, two screens. So how can I divide my SolidWorks screen into two? We are going to discuss that also. So we will do what we can. Uh, if I want to divide the screen into two, now here this method is somewhat different. So I have to select what is the base part. Say I'll just double click and open this. Now when you double click and open this base part, it's going to be open in a part mode. So you can see it's now open as a part file. So if you double click, it will be a part file. Now this is the assembly mode. So you can quickly look at this is assembly. So I will just take this base in the assembly mode and this as this in the part mode. So I'm going to just open this, or you can double click on this. Now this is in the part mode. So I have opened two SolidWorks screens. One is assembly, drag and drop assembly, and the other one double click, open part mode. So now I have, if you have two monitors, you can open these in two monitors. Now since I don't have two monitors, I have to split the screen into two. So how can I divide the screen into two is, there's a tool called window horizontally or tile vertical. So I can tile the window horizontally or vertical this way. So this is in assembly mode, this is in part mode. So what we can do now is we can just select this one and drag and drop here. So you can see assemble has been made. Uh, Now it's assembled. So if you just look at the mate here, some mates have been applied. So I didn't actually start any of these tools. I didn't go and start these move tools. I didn't go and use these mate tools. I just dragged and dropped the parts, and it was assembled. So this is the fastest way of doing this. We are using the geometrical relationships between the parts. And if you have a lot big monitor, you can open several parts and drag and drop to the main assembly and finish this. So I will do it again and show you. So if you have a big monitor, several screens, this is the fastest way. So anyway, you have to start an assembly file. This may be the main assembly, final assembly. Open the, put the base part here as assembly file. So this is assembly. And other parts you double click or right click and open. So you can right click also. Sorry. Double click or right click and open this. Say I'll double click and open. Now this is in the part mode. You can quickly see this is in the part mode. I have two screens now. So I have to divide the SolidWorks into two. So we can come here under Windows. We can tile vertically or horizontally. So I tile horizontally. So this is my assembly. This is my part. Then what you can do is you can use these geometrical properties of these edge or these faces and drag and drop to here. So you see coincident and concentric both are happened. Now it's done. So if it is okay now, you can just close this part file and your assembly is now there. If you just look at it, two mates have been done. So I didn't use this move tools here. I didn't use this mate tools here. So I just dragged and dropped the things and did my work. Any questions? Please tell me. I will repeat or I will explain. So this is the process. Open this in assembly mode. This is in part mode. You will select a geometric which is matching this one and drag and drop here. Divide the screen and drag and drop here. It will automatically assemble. So that's how it works. So it seems no questions. I will do another application uh, example and show you. So same concept. They have given a name called feature base. So you can get the geometrical shapes of features and assemble. And it says here applied only to the components that have cylindrical or conical features. Cannot apply to two features. So you have some restrictions. Remember, sometimes this may not work. So we have cylindrical faces. So that's why it's working. So we will look at how to do this example, previous example again. So I have to start the main assembly. Then I'm taking the previous example. So they have taken the same previous example. So this is opened as assembly. This is in assembly mode, and you double click and open this in the part mode. So I have two SolidWorks files now, and we can go tile this window horizontally or vertically. You can either tile vertically also, no issues. Now this is assembly mode, this is part mode. You can do what? Just drag and drop here. You can see it's working. Now it's done. So if you want, you can delete this part now. It's not needed. And now one mate has been applied. Then if you want, you can use these move tools, smart tools, and what we discussed earlier. We double click here and drag and drop here. So that is a smart move I did. Then if you want, you can use a traditional method and just make it coincident, concentric. So this is the way I did it. I have used three ways. This is the smart track between the files. This is the normal smart move. This is the traditional method. So whatever the process you use, do it quickly and accurately. That's the most important thing. So you can try this also and see. Any questions, please inform us. Okay, so if you are finished with this, I will go through this example also. Similar method. Uh, now, if you try to assemble this kind of a flange, you have to do a lot of mates to align these screws. So the holes should be aligned. So that may be somewhat time consuming task. So I will just do this in a smart manner and show you how to do it quickly. So we will use the same method we discussed previously. Uh, some it's already done for you, but I will use the normal files and do it. So I will take the pipe which is not assembled. So you can drag and drop this. This is in assembly mode, and this one can be opened separately. Now this is in the part mode. So I hope everyone can draw these kind of things at the moment. So we have done this kind of a tutorial last semester. So we will tile it. Now this is in the assembly, this is in the part mode. So you can do what? We have to have something like this kind of orientation. So we can orient this uh, part before getting into the screen. So you can do what? You can just try to get this edge here and try to assemble with this edge. So it happened, but it's not coming in the correct orientation. So you can see it's happened, but it's not coming in the other way. So the problem here is there is a default orientation to this, so that's why it's not coming in the correct manner. So if I just try it with this edge, now it came. So because this is the same part, you may try this edge or that edge, so it will work. Now you can see it's nicely aligned. The holes are nicely aligned. So I don't need to do a lot of mating by myself. So we can just switch off this part mode and see what are the mates has been done. So concentric has been done, concentric holes has been done, coincident has been done. So it's a fully assembled part, no minus sign. So it's nicely done. So I didn't do a lot of work here. So I just drag and drop and did it. So you can also try and see any questions, tell me. So we discuss this assembly method, assembly, this assembly, and this one using drag and drop. These are smart ways. These two are smart ways. So you can either use a mix of techniques or just use the drag and drop this way and complete it. Some slides I'm skipping. Actually, we are doing it anyway. Later we may cover. So don't worry about that. So we are covering everything. So uh, we have the last topic here before the tutorial. This one. So any questions before starting this? So if you don't have the questions, we will uh, we will look at the last topic before the tutorial. So this is called assembly visualization. So what do you mean by assembly visualization is you can give colors to the parts. Normally, when we start the parts, we can give the colors. So if you we ask you to give different colors, then it's easy to visualize or distinguish the parts. Now, if you want, you can give us temporary color in this mode also. It's called assembly visualization. And if you want to measure the weights and the other properties, can be done. So there's a tool under evaluate. You will find a tool called assembly visualization. So if you just click on this, it will show you. I have only two parts here. It will show you some color bar, and if you just click on the color bar, it will uh, give you some color properties. But here we got the same color because this is the same part. So and they will give you more information here. This is the mass, and if you want, you can get the other or information of the part also. Now, if you have a good part better than this, say good assembly, I will open a good one. So last time we discussed this bench wise. We completed half of the drawing. So this has several parts. So if you run the assembly visualization, now it has given some three colors, almost three colors. You can click on the color bar here. It will show you the mass properties and the quantities one piece, one piece, one piece. Then one piece, one piece, one piece. Then it will show you the masses, and if you want, you can get the other information also, say the volumes or the surface areas. So sometimes in the exam, we may ask you to give a screenshot of this, or we will ask you to measure the weights and give us. So if you want, you can go to more properties and get the other density is not shown because the material density is measured in millimeters per kilograms. So millimeters per gram, if I can remember. That's why you cannot see the density. So units are very small. So that's why you can't see the density. Say if I just go and check the units, unit system we are using, we use millimeter gram seconds. So the density will be in millimeters grams per millimeter cube. That's why you can't see that. So if you want, you can change it to kilograms per meter cube. So there's no problem with that. Uh, so this is another way of getting a printout or visualization. So if you want to color it and show it to a customer, this is the easiest way. If you just click on the bar again, it's the raw colors, and it will give you some colors. So if you try and right click and use the group identical, so it will give you some other color variations also. So this is if you have a big file like this, you can have nice variation. So when the parts are getting bigger and bigger, you can have lot of colors in the assembly visualization. So this is all about chapter 12. So next week we will look at advanced mates like advanced mates like uh, with mate, path mate, symmetric mate, profile centers, and I'm going to start the mechanical mates soon. Cam, slot, hinge, gear, rack and pinion, screw, universal joint. So these are the advanced kind of mate mechanism. So for the exam, we will ask these kind of questions from these areas. So you can we will do the tutorial number one. We will try to complete the tutorial number one and tutorial number two today. So we have one more hour. So I'm actually I have a meeting now. So I will give the host to Mr. Sean. So he's my partner in this subject. So I hope you know about him. So I will transfer the host to Mr. Sean, and he will continue the lesson. So I will stop the video for time being, and he will record the video, and we will upload the videos soon.